Hey guys, I'm here with my two buddies today, my two helping buddies today. Hopefully he won't interrupt our lesson too much. As you see, I've already started it because he did interrupt it and hit the phone and it fell. So I had to start over. So we're gonna do that. All right, so this is telling you how to get from, oops, I'm sorry, I shook the table. How to start percents, just a different way. We learned it yesterday with double number lines, which again, I told you was not a way that I'm accustomed to doing it, but it is a way to do percents. And I'm gonna show you the way I like a little bit better. And then you can kind of choose for yourself, whichever way you think works the best for you in the future. All right, this is just giving you an idea of how do you get from 100 to 106, okay? If I multiplied this out, if I wanted to get from 100 to 100, I would multiply it by 1. If I wanted to get to 100 to 6, I would multiply it by 0.6, because remember, anytime you multiply by 100, you move the decimal twice, or if you divide by 100, you move the decimal twice. That's how I would get 106, okay? So same thing here. If I did 100 times 0.9, I'm going to get 90, because that would be 900, and then I would move the decimal over one place if I did 100 times 9. So if I do 100 times 0.9, I'm going to get 90. Now moving backwards, how do I get from 90 to 100? And you're like, I don't know, how do you get from 90 to 100? Well, if I worked backwards, if I said, okay, well, I know I had 90, instead of multiplying, I divided by 0.9, I will get 100, okay? Same thing here. I had 106. I'm going to work backwards. I'm going to divide by 1.06, and I should get 100, okay? So that's how you would do those type of problems. They're a little different. All right, now here's the way I do percents, that I like the way to do percents, and I've always taught this way. There's two different ways, and sometimes it's easier to do an equation, and sometimes it's easier to do a proportion, okay? But this is the keyword you look for, is over of or part over whole has to equal the percent over 100, okay? In a problem, if you have a percent symbol, it has to go above 100, okay? I don't care what words around it, what else is in the problem. If there's a percent symbol, like this has 6%, that would automatically go over 100, okay? No questions. If I don't have a percent symbol at all in my problem, then that's where my variable would go, okay? So, and I look for the keywords is and of, or part in whole. Part in whole sometimes is easier with story problems. If I have something like, what is 10% of whatever, using the words is and of work very well, okay? And if you're doing an equation, of always means times, okay? Is always means equals. So sometimes you can go word for word on them. All right, so it kind of depends on how the problem's written. Sometimes I do equations, sometimes I do this, and then I looked at the double number line. Sometimes I could do that. So there's different ways to do a percent problem. All right, this one says money in a particular savings account increases by 6% after a year. That means it went up 6%. How much money will be in the account after 1 year if the initial deposit, this is what you started with, this is the whole, okay? This is what you would call the whole. Okay, that's what you started with. That's where this goes, okay? So if I were I would do a proportion on this. I would say I know the percent, it always goes over 100, is equal to, okay? I know that it was $100. I'm looking for, now this is gonna tell me how much it increased. It's not gonna tell me the new amount, okay? This is going to be how much it increased. Because if you think about it, I put $100 in my account, so if it's going to increase, it's got to be at least $100. So if I go to solve this, remember how you do proportions, you cross multiply and then you multiply the numbers that are, and this is a pretty easy one because you would do 6 times 100 divided by 100 is going to give you 6, okay? So I would do 600, or I could say it's got to be a 6 because 6 over 100 equals 6 over 100. Oops, not divided by. Equals 6. So it increased $6. okay? Now, it's saying how much money will be in the account after a year. You had 100, it increased 6, so now you will have $106, okay? You're not just gonna have $6 because that means your account didn't increase at all, okay? That means it decreased, and that's not a good thing. All right, so I can do the same thing with 50, and there's another way to do this with a proportion too, where you don't have 2 steps, and I'll show you that, and I don't care which way you do it, okay? So this one says, okay, how about if your initial amount was 50? So I'm gonna set everything up the exact same. It still went up 6%. Get back to my purple. So 6 over 100, because it's a percent, it goes over 100, is equal to, now my original amount was 50, and that would be X. Okay, now these numbers are easy. I could do 50 times 2, so what times 2 is 6, but I'm going to do it as if the numbers aren't that easy. So this would be 6 times 5 is 30, so 300 divided by 100 equals 3. Okay, it increased $3. That does not mean you have $3. It increased $3. You had $50. It increased $3. Now you have $53. Okay. All right, let's do 200. I'm running out of room here. I'm gonna have to move up here because you know how big I write. Oops, I was using purple. All right, so this one says, okay, if you had 120, if you had $200, set it up the same way. This is gonna go way up here. So this is a 200. So I'm gonna say equals, always start like that. Every proportion problem should start like this. 100 goes here. My percent, I know, so that goes there. I started with 200, this goes here. My X would go here, okay? And again, what divided by 2 is gonna get, 200 divided by 2 is gonna be 100, so that's gotta be a 12. But if I did this, it's not really that hard of math. 6 times 2 is 12, that'd be 1,200 divided by 100, gives me $12, okay? Again, it did not just increase $12. It increased the 200 you had plus the $12 increase. What you had, how much it increased is equal to $212, okay? Okay, so I'm gonna show you a little different way. I wouldn't do an equation on this one just because I think the proportion's a little bit easier, okay? But let's look at the $125. Now, I'm gonna tell you a different way to do this so you do it all in one step. It just depends on how you wanna do it. So this is gonna be the 125 down here, okay? I know I'm all over the place. Okay, so if you noticed, when I started with $50, I added $3, I ended up with $53. Would everybody agree that $50 was 100% of what I started with? Okay? This was 100% of what I started with. This was the 6% of what I started with. So that means $53 was 106%. So what that means is, rather than doing it 2 steps, I could do it in 1 step. So again, I'm gonna put my 100 equals, okay, I know my 125 goes here. Now, instead of 6%, I'm gonna say, well, I really want 106% because I want the 125 I had, plus I want the 6%, so I really want 106%. Okay? Now, if I go to multiply this out, I would have to do, so that means I'm looking for, this will give me everything all at once. Okay, I won't have to add them together. So if I do 106 times 125, which I don't know what that is, so let me get my little calculator going here. I wasn't thinking ahead. Okay, so if I do 106 times 125, I get 1,300, 250, and then I'm gonna divide by 100. Remember, I don't need to divide that out. You move the decimal 2 places to the left. Boom, boom, okay? So I would end up with $132.50. That will give me the increase and the total all in one, okay? So that's just 2 different ways to do it. But your percent always goes over 100. This is what you really need to know, okay? That is the part that's really important in this lesson. Really easy way to find percents. And you can use a calculator for the numbers, so that's not a big deal. All right, let's go on to question 2. It says the value of a new car decreases by 15% in the first year. How much will a car be worth after 1 year if its initial value was 1,000? Okay, so again, there's 2 ways I can do that. A decrease of 15% is the same as, so if it's a decrease 15%, it's the same as me paying 85%, because 85 plus 15 gives me 100%. So again, there's 2 ways I can do this, and I'm going to do it both ways. I'm going to do one way and one another way, okay? So again, I'm going to do is over of, just because it's easy. This equals this over 100, over 100, okay? Now, it's telling me it's 15%, so I'm going to start there. I started with 1,000. I want to know how much did it increase, so I'm going to do 15 times 1,000, which is 15,000 divided by 100, which means I go boom, boom, I get 150. Okay, now, what it's saying is it decreased about 15% in the first year. How much will a car be worth if it was 1,000? I would have to subtract that. Here's what it was originally minus what it decreased, and I'm going to get $850. So if I bought it at 1,000, it decreased $150. Now it's at $850. Okay. Now I'm going to do that same problem in one step because it's easier when it's a decrease for sure to do it this way. So if it's 15% less, that means that I have only 85% of it. So if I did, it was 1,000, instead of doing 15, I'm going to say, well, I really have 85% of it, the total. Okay? So this is going to give me the amount I want because it's saying it decreased 15%, so I only have 85% of it. Oh, little guy's going to get in the way here. So I would do 8,500, excuse us there, kitty, divided by 100, or 85. Did I divide by 100? 85 times 100, 8,500, okay. I totally lost my train of thought, and I hate when that happens. Oh, this was 1,000. That's why I lost my train of thought. That should be one more zero. I'm like, that's not going to work. I'm sorry, that was 1,000. So I'd have 85,000 divided by 100, and I'm going to get $850. Okay? So that is one way to do that. Now, when you're talking about an X, and I didn't do that on purpose on the other side, okay? I'm totally out of room to write this. So I'm just going to steal another piece of paper and write it on that one. All right, some scrap paper I have. If I have the X, now I know this is like the meat of the percent, so that's why I'm going over this so slowly. Okay, so if I have an increase, okay, so it's going to be the total over the original. Original is always what you started with, is equal to 100% plus percent of increase you guys can't see that, can you? All over 100. Okay, so when I was doing the 6% increase, what I said is I'm looking for the total, so that's where my X went. It was over, let's say it started with, I don't even know, 125 is equal to, it was 106 over 100. It was the 100% plus the 6%. Would you move your butt out of my face here, buddy? Oh, it's cute as could be. Okay. Or, I know there's so many different ways to do this. If it's an increase and I want 106%, the equation way to do it would be 1.06, I'm going to say times X. So that's how I would do it. I'd say if I want 106% of what number, is the total. So if I started with, let's say it was 300, I do 1.06 times 300 would give me the total. If I started with the 50, I did 1.06 times 50 equals the total, okay? For a decrease, I know this is a lot. There's so many different ways to do, what do you call them? Percents. And it truly just, you gotta think about what would make sense. So in this one, what I did is the decrease was the 100% minus the decrease, okay? So I did like, if I were doing 5,000, I would say x over 5,000 is equal to the 100% I started with minus the decrease percent over 100, okay? So in this case, I decreased 15%, so I would do 100% minus 15% gave me 85%. And then I could figure out it that way. Or I could have done 0.85 times x. 85% of the total of the original is the total. So this really means I just changed my percent to a decimal. 85% of times, remember there's times there, of original equals the total. Okay? All right, let's try some different ones. And these are going to be the equation ones, so let's think about it. This says match an equation to each of the situations. So the water level in a reservoir is now 52 meters. If this is a 23% increase, okay, so this means I need 100% plus 23%, which is 123%. If I change that to a decimal, you move it twice because that means 123 divided by 100. That's what percent means, divided by 100. So this is really 1.23 of some number equals what it is now. So this one matched over here, okay? This one says the snow is now 52 inches deep. This was a 70% decrease, okay? So if it was a 77% decrease, I'm gonna do the 100% minus 77%, and I'm gonna get 23%, okay? So it's saying it's 23% of some number. Excuse me, head sneeze. Of some number is 52. So I'm going to change this to a decimal. That's how you do it with percents. These have to be a decimal. I can't use the percent thing. So divide by 100 would be 0.23 of some number, we don't know what it is 52. So this one would be that one, okay? All right. We're not gonna do too much more of this. Okay, so we're gonna skip this right now. Run out of time. Okay, this one says, okay, the gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. We did this on the double number line, same thing. How much gas does the truck's tank hold? Explain why this situation can be represented by 1.5 times 12 equals T. Okay. So we're looking for what Mom's car holds. Mom's car holds 50% more. So hers holds 100% plus the extra 50%. That's where this 1.5 comes in. If I have 150% and I change that to a decimal, that means I move it back twice. Of what Dad's holds, the 12 gallons Dad's holds, and that's going to equal Mom's. Okay, if I looked at it that way. So if I wanted to figure that out, I would just do 1.5 times 12, which is going to be 12 plus 6, 18. So Mom's tank holds 18 gallons. Okay? And we explained what T was. It says explain what T is, and that would be what's in Mom's tank. Okay? All right, let's write an equation for this one. A movie theater decreased the size of its popcorn bag by 20%. If the old bag held 15 cups of popcorn, how much does the new bag hold, okay? So this was my original. I'm gonna say it decreased 20%, so that means that's 100% minus 80%, 20%. 20% is 80%. I know what I'm doing. Okay, so you're saying you have 80%, which would be 0.8 of the 15 equals what the new bag holds, okay? So I would just figure out what 0.8 times 15 is. What's 8 times 15? 80 plus 40, 120 is 12, okay? So if I multiplied this out, I would get the new bag holds 12. And it makes sense, it decreased. So my number better be less than 15, okay? All right, next problem. We're rocking through this now. After a 25% decrease, which means you're paying 75%, okay? 100 minus 25 equals you're paying 75%. The price of a t-shirt was $12. What was the price before the discount? So what is this price? Okay, after the discount, it is $12. So that's how I would figure it out. This is my original price. This is my new price. That's how your equation's always going to be set up, original. So I would say it changes to a decimal, which would be 0.75 times the old t-shirt price is the new t-shirt price, okay? And I'm going to solve that just like I would solve an equation. I'm going to divide by 0.75, okay? I'm going to solve it just like any one-step equation. Divide by 0.75, divide by 0.75. If I go on my calculator and I do 12 divided by 0.75, 12 divided by 0.75, I get 16. Okay, does that make sense? It was decreased, which means it was more the first time. Okay, so I know I'm correct. I gotta kind of go back at my problem and make sure that I didn't get these two numbers mixed up, because if I end up with a number that's bigger than I start, then, I mean, a number that was, I need a number that's bigger than 12, but if I had started out with a number that was smaller than my discount, that doesn't make sense. All right, last problem on here we're gonna go through. Compared to last year, the population of Boomtown has increased by 25%. Increase means it's 100% plus 25%, okay? So I know it's 125% now. The population is now 6,600. What was it last year? This is my original. That's where you started last year. This is the new population. This is what it's equal to, is, okay? So I'm gonna change that to a decimal, 1.25 times the original is 6,600, okay? And again, I'm gonna go through that and solve that equation. Divide by 1.25, it's one-step equation, 1.25, and I'm gonna tell you what that is because I'm doing it on the calculator. So I do 6,600 divided by 1.25, and I get 5,280. Okay, does that make sense with my problem? Sorry, my paper didn't go up. It was 5,280 people. It increased 25%. Now it's 6,600. Yes, it does make sense with my problem, okay? Now, if I would have switched these numbers around, it would not make sense. But then my last year's population was bigger than 6,600. So that's how you always know you're right. You always got to go back into that problem and say, does this make sense with the problem? It's very easy to mix these numbers up. And if you do, you just go back and say, oh, wait, I got to flip these numbers around, okay? All right, that is it for our lesson. I know it was kind of a lot, but there's a lot of notes on here, and I'll definitely send you a copy like I always do, and it would be really good to go through these again, and I know it makes more sense with the video, but hopefully it'll, you know, if you need to watch certain parts of it again, that's great. Have a fantastic day, and I'll talk to you guys later.